So in the previous tutorial, we talked about arrays, and arrays are just a sequence of data that we can store in a single variable, and how we can set a specific size based on how much information actually can be stored in that variable. But I also talked about another structure that we can use that is similar to an array, called a slice. Now there is a difference, and the difference is why slices are usually more popular to use than arrays. Now the difference between a slice and an array is that slices doesn't have a specific limit. They can shrink and grow based on your needs. We know how arrays, once we create an array, there's a specific limit. So in the previous tutorial, we used array called boxes, and that had a limit of 10. If we went over 10, it would get really mad, and it would let you know that you can't go over that specific amount. But with slices, we can go beyond that. It grows and shrinks based on what we need, and that's what makes it so popular to use in Go. Because usually when you're using an application, you don't exactly, sometimes you may not know the amount of stuff that you may enter into a structure like an array. And if you don't know the amounts, you don't know your limits. And if you don't know your limits, then it's kind of hard to play with arrays because it gets mad when you go over the limit. So that's why slices are so popular. So let's figure out how we can create a slice and how to use a slice. So to initialize a slice, all we got to do is we're just going to create a slice called S, right? And we're going to let them infer what this is going to be. So I use a colon and equal, open up brackets, specify a type. So I'm going to specify it as an int and open up some curly braces. This is how you create or how you initialize a slice. Before, we would have to specify the amounts. So we would have to use like 5 or 10 or whatever before we use 10. But for a slice, we don't have to specify the amount because it grows and shrinks based on our needs. Now, how exactly do we add to this slice? Well, first we can, provide some initial values. So if we wanted to, add some ints, we could. And I can print this out. You guys can see how it looks like. So let me just print out S. Go run. And now we can see that we created a slice for 1, 2, and 4. So it looks just like an array because a slice is literally built on top of an array, but now we have the ability to use it without setting a limit. So we initialized a slice with 3 values, and we can still get the length if we needed to. So right now we know that the length is 3 because there's 3 things inside of it. But another cool thing about a slice is that there's a thing called capacity, or in this case, instead of it being len, it'll be capped for capacity. Now, what capacity does, it returns the capacity of the slice, the number of elements the slice can grow or shrink to. So let's run this. And in this case, there's 3 things in the slice. So the amount that the elements can shrink or grow to is 3. Now, if we remove 1, then it'll be 2 because there's only 2 things in the slice. Now, usually capacity and length intertwine, but later on in the video we'll see how we can set a specific capacity for a slice. So that's the difference between another difference between an array and a slice. It also comes with another function called capacity that we can use to check the number of elements that the slice can grow to or shrink to. We can also create a slice from an array. So let's bring back boxes, and I'm gonna let it infer the type. So we're gonna create 1, and we're gonna make boxes of size 5. We're also gonna make this an int, and I'm just gonna do 1, 2, 3, 4, and 5. Right. Now another way we can do it, we could take a slice of this array, right? So what we can do to get a slice of this array, meaning we'll just take a piece from this array. So say for instance we just want 1, 2, and 3. How we can do that is we can just take the variable called boxes, which is holding this array of 1, 2, 3, 4, and 5, and to get a slice or to get a piece of this array to make the slice, we can simply put, since we know we want from the beginning to a specific amount, so in this case we want 3, we add a colon, meaning that this colon just pretty much let Golang know that we want the beginning, so everything from the beginning to a specific amount. Like if we didn't put any numbers here, so let me try to write it out. So we can do start, which means that the start will be a value that we put in the beginning, and then the colon will be like the separator, and then the end. This would be like, you know, the end value. Now, if we don't put a start and an end, we're pretty much letting Golang know that we want everything in that array. So in this case, we will take 1, 2, 3, 4, and 5. And let me print this out so you can see that. So if we print out S, and I clear this out, and we run this, you will see 1, 2, 3, 4, and 5, because we're letting Golang know that we're not specifying a start and an end, so we just want everything. But say for instance, we want to specify an end, right? We want to end after we get this 3. So we know that there's an index of 0, 1, and 2. So once we get to 3, we can stop, we can end it. But we're not going to include, you know, this third index. So let's do that. Let's do everything up to the third index, which is 4. But we're not going to include 4. So let me run this. And you will see 1, 2, and 3. Yes, this can be a little bit confusing. But just remember, we're getting to that index of 3, but not including it for the ending piece. But for the beginning piece, right, if we were to put 0, this is included. The start is included for this slice. Just remember that the ending piece is not included. So whenever we put a number or index here, it's not including that ending piece. But if we put a number here, it is going to include that value for the start. So we can run this again. It should print out the same result. So it's still going to print out 1, 2, and 3. And if we just want 2 and 3, we can just do from index 1, which is 2, up to the index of 3, but not including the index of 3. So let's print that out. And it's just going to show 2 and 3. And we can also remove the ending index, and it will go from index of 1 to the end. So we know that the last index is 5, so we can just save this and print it out. So it should do from 2 to 5. So yeah, you can see it's 2, 3, 4, and 5, but it's not including the index of 0. So because we specified that we want to start from the index of 1. So yeah, this is powerful, because we could just take bits and pieces of an array that's already created and create a slice out of it, and we can continue to, you know, expound or grow upon that slice that we created. And how exactly do we do that? How exactly do we add on to a slice that we created? We can use a function called append. So to use append, all you got to do is first take the variable that's holding the slice and make that equal to append, which is, you know, just spelled append. And we take the slice, which is already like trying to fill in for us. The slice is being held by S, so we use that. And now we can place the value that we want to add to the slice. So I want to add on 6 because we're already taking from 2 to 5, so let me add 6 right after. And the reason why we have to set the slice equal to the append of S, and you know, the value that we're trying to append, is because append, all it does is it takes the current slice, it adds the value, and it makes a new slice. So you can, even if you have VS Code, you can actually hover over this and see the explanation. So it says, if it does not, or actually right here it says append returns the updated slice. It is therefore necessary to store the result of the append, often in a variable holding the slice itself. So we're doing exactly that. We're taking S, which is holding the current slice. We're using the append function, which is just going to return this slice that we had before, but the value that we're trying to insert into the slice. And that's going to be technically a new slice, but we're just going to set it equal to what was holding the old slice. So after we do that, and let me just print out both cases. So I just put one right before the append and clear this out. If we run this, we should see initially 2, 3, 4, and 5, but after we do the append and we set it back to the variable that's holding S, you're going to see that 6 is added as well. Now, when using append, you're not restricted to just inserting one value into the slice. We can continue to add values using the same append function. So say for instance we wanted to add 7, all we got to do is add a comma and add in the additional value that we want to append into the slice. And you can see here what slice takes in is what the append function takes in is a slice, but it also just take in a series of elements. So we're not restricted to just one. We can add in as many as we need as long as it's matching the type of the slice. So if we want to add up into 10, we could do that. And I can print this out to prove it. So you can see before it was just printing out 6, but now it's printing out up to 10 because we are adding or appending those additional values using the same append function. So that's how you use the append function, and that's how you add on values to a slice in Go. So I want to show one more way how we can create a slice in Go. So let's do that really quick. Let me erase all of this. And I want to create, or I want to use a function called make. And let me just write this out in a comment really quick. So make takes in 3 parameters. It takes in the type, it takes in the length, and it takes in the capacity, right? So before we talked about how slices doesn't necessarily need a length or capacity, but you know, you have the option to add it if need be, right? It won't restrict you. There's no a limit, but what a slice does on the background, right? What a slice does is as you add a value to a slice, right? The runtime doubles the capacity every time it exceeds a capacity. So say for instance you create a slice of a capacity of 4. In the underlying, you know, Golang code, what it does is it makes an array that is of size 4. Right. So whenever we go over that capacity, it creates another new array with a capacity of 8. So it doubles it, just so that it has enough time before it has to double it again and again and again. So to save on, you know, memory allocation for it and having to do that multiple times, you could set it up with a initial capacity before it does have to do that logic of doubling up space to handle the slice that you created. So say for instance you start out at a length of 4, and then you have to double up it to 8 and double up to 16, double up to 32. Instead of just starting at the capacity of 32 from the beginning, if you know the capacity that you want to use from the beginning, you might as well use the make function to actually do it, instead of, you know, having to allocate memory each time to do that logic in the background. So it's really a personal preference. It's relatively fast for smaller you know, slices, but if you're messing around with big huge slices at the for your application, then this is something that you can look into when creating a slice. But let me show you how it's done. Let's do a make. So all you got to do is get the variable that you want to store the slice in. So I'm just going to call this s again. And I'm going to let Golang infer it. Use the make, and I'm going to pass in the type of the slice that I want. So just open up some brackets. I want it to be of type of int, and let me just give it a length, and we should be good to go. Now it's just showing s because we're not doing anything with it, but if I print it out, we should just see an empty slice of zeros. Let's print that out. And let me clear this out. Go run. Boom. Because we set the limit, we set the length, I mean, but we could also set the capacity if needed. So say for instance we know that we can store up to 10, we can do that. But we know the length is going to be 5. But the capacity is that if we ever get to 10, then that means we have to double up the memory allocation. So now we have to set up a capacity of 20 of what the slice can actually increase to before we have to double up the space again in memory. But this is another way we can make a slice, and we can still do the same logic if we want to retrieve something. Just use the index. So if we want to grab 0, or even if we want to set a value, we can do that. Set it to 12. We can still do the append if we want to. Take s, add in a 4. And we still got to, you know, set it equal to the new slice to the old slice variable. And if we print this out, and let me just print out everything to show that everything took into effect, run it, we can see that 12 is at the beginning as we, set the index of 0 to 12, and we also appended 4 at the end to that. So yeah, and it's, as you can see, like, we're not limited just because we put 5. We're not limited to using just 5. It's just setting the initial amount to 5. The capacity is 10, so once you get past that 10 threshold, we'll just double up, or Golang will do its magic on the inside to double up the capacity and memory for it. But like I said, if you have a huge application and you know the capacity, then it's better to set up initial capacity at first, so that Golang doesn't have to set up a huge amount of allocation each time to create a capacity for your slice. So like I said, it's things to think about, and you can see how powerful slices are. I would play around with this, but yeah, and even if you want to print out the capacity, you can do that too. Like I said, just use the cap and print out that the capacity of S. We can print out the capacity of, or the length of S, and do that with len, and they should all print out on a new line. So we should see that right now the length is 6, the capacity is still 10 because we created this slice with a capacity of 10. And you can see that it's different because before, when we initialized it without setting a capacity, it just took the actual length of the capacity. So if we were to add in a new value, then it would just double the capacity based on the length. But we see right now there's 6 because there's 6 values in here, but the capacity is still 10, and it has everything that we had changed. So slices are powerful. I would advise playing with it. It's usually what is used over arrays because of how powerful it is, and that we don't have to set a restrictive limit on the things that we want to add on to the slice, like an array. So yeah, that's slices in Golang.